Hi, this is Dr. Swapna welcoming you all to my channel, Your Learn Lab. Today, we will be learning One-Way ANOVA. This is a very important topic that comes every year in the term end examination of BPCC 108, which is Statistical Methods for Psychological Research, Part 2. This is one of the core papers for BA Psychology Honours students of IGNOU. Now, before I start with the lessons, let me give you a quick information on the pattern of question paper for BPCC 108. The question paper has two parts, part A and part B. Each part has 4 questions each. So a total of 4 plus 4, 8 questions. Each question carries 10 marks. You have to attempt any 5 questions. Here, what you need to remember is that it is compulsory that you attempt at least 2 questions from each part, which means you can attempt 3 questions from part A, 2 from part B, or 2 from part A and 3 from part B, making a total of 5. This is totally your choice. Now, out of the 8 questions, there would be statistical problems to solve. These would be the most scoring and least time consuming questions you should aim for. Generally, you get 3 of these questions. Now, if you analyze past 10 TEEs or the term end examinations, you will see that the pattern hasn't changed much. The 3 statistical problems would be from these 4 topics: One-Way ANOVA, Mann-Whitney U-test, chi-square test, or the Kruskal-Wallis ANOVA. In this video, I'll be teaching One-Way ANOVA, but I'll be dropping videos for the other 3 pretty soon. Now, how are we going to study? We'll study the basic theory of each of the 4 statistical tests. We'll learn how to compute each of them, and then we'll solve the questions that were asked in past few previous year TE question papers. I suggest you sit with a book and a pen. It would be easy if you solve questions along with me. Let's dive into the lesson now. What is ANOVA? ANOVA stands for Analysis of Variance. It is a statistical test used to analyze the variance between 2 or more groups of data. This means if you have 2 or more groups of observations, you will perform ANOVA test to check the variance among the data sets. Now, naturally, the question is, what is variance? Let's do a quick recap. The term variance was coined by R.A. Fisher in 1913. It is mathematically defined as the square of standard deviations. Variance is a measure of dispersion of a set of data points around their mean value. What does this mean? This means variance tells how spread out a set of data is from the mean, or how far each data point is from the mean. Variance also tells how close the data points are to each other. Let me explain this with a quick example. I have a set with 3 observations, 2, 5 and 8. When I say I need to find the variance, this means I have to find out how spread out these 3 numbers are from their mean. And for that, first of all, I need to calculate the mean of these 3 numbers. How do we calculate mean? To find mean, we have to add these 3 numbers and then divide it with total number of observations, which is 3 in this case. So, we add these 3 numbers, we get 2 plus 5 plus 8, 15. And then we divide it with the total number of observations 3 and we get the mean as 5. So 5 is the mean of these 3 observations, and now we have to find out how each of these numbers are spread out from the mean 5. For this, what we do is we'll subtract 5 from each of these points. I have tabulated it here for you. So we are subtracting 5 from each of the data points. So 2 minus 5 minus 3, 5 minus 5, 0, 8 minus 5 plus 3. This means the data point 2 is 3 less than the mean 5. The data point 5 is exactly at the mean. And the data point 8 is 3 more than the value of the mean, which is 5. So since here we have a minus 3, we'll have to convert this into a positive value. And for that, we'll square all the 3 numbers that we have. Now, what are these 3 numbers? These are the difference of each of the data points from the mean. So let's square these values now. So squaring minus 3, we get 9. When we square 0, we get 0. When we square plus 3, we get plus 9. So now, what are these numbers? These are the squares of the differences of our data points from the mean. Now, to find the variance, all we need to do is find the mean of these three numbers, 9, 0 and 9. So we have already calculated mean once. How are we going to calculate it? We'll first add the three numbers, 9 plus 0 plus 9, and we get 18. Then we divide the number 18 by total number of observations, which is 3, and we get 6. So the variance of our data points is 6. Now, we said that mathematically variance is defined as the square of standard deviations. So, if variance is equal to square of standard deviations, then what is standard deviation? It would be square root of the variance. So, here the standard deviation of our data is root 6. I hope you understood the basic concept of variance. ANOVA can be used for independent measures and repeated measures. What does this mean? Independent measure means there is a different sample for each treatment or condition. Let me explain this with an example. I have a class of 50 students. I want to check the efficacy of my teaching on my students' understanding of ANOVA. How do I find out that? I can go about it in two ways. In the first way, I'll divide my class into two groups of 25 students each. The first group of students, I'll ask them to go and study ANOVA from any other source. It may be internet or some other teacher or a book. The second group of 25 students, I'll be taking the class myself. So I'll give 1 week for both set of students, and at the end of 1 week, I'll take a test. The results will tell me how effective my teaching methods are compared to other methods that my first group of students have used. So in this method, I have different samples for each treatment or condition that I have used to find the result. This is independent measure. Okay, there is a different sample for each treatment or condition. So in my second method, what I'll do is I'll take a test on the same group of 50 students before I take the class. Okay, so before I actually teach my class of 50 students, I'll take a test and see how much they know about ANOVA. Then I'll teach them for a week. At the end of the week, I'll take another test. So this will tell me how my teaching has helped them understand ANOVA. Okay, so what I'm using here, I'm using the same sample for different treatments and condition. It is something like the before and after situation. So this is independent measure and repeated measure. The next concept that we need to understand is that ANOVA is a parametric statistic. Now what does that mean? This means ANOVA meets certain assumptions. What are these criteria or assumptions that ANOVA meets? The first assumption is that the data is normally distributed. Again, what does this mean? This means if you plot all your observations on a graph, you will get a bell-shaped curve like this. This is a bell-shaped curve. So, if you plot all your data, and you get this kind of a curve, then what you're dealing with is a parametric statistic. And if it doesn't make a bell-shaped curve, then it is a non-parametric statistic. The second criteria is that the variance must be homogeneous. Now, what does this mean? If I take two or more samples from a population, okay, I'm taking random samples from a population. How do I know that these samples exactly represent the population? I'll calculate the variance, and if I have like same variance for all the sample groups I have taken, then it proves that the samples represent the population truly. So this is another assumption that ANOVA meets, that there is a homogeneity of variance among all the data groups. The third assumption is that each observation must be independent of each other, or one observation is not dependent on the other. The fourth one here is that if there are multiple factors affecting variance, then the combined effects should be additive in nature and not multiplicative. So if any of your statistic assumes all these 4 points, then we call it to be parametric statistic. Now we have two types of ANOVA, okay? We have one-way ANOVA, which examines the effect of a single factor on a dependent variable. Example, if I want to study the effect of my teaching method on my students' understanding, it is one-way ANOVA because there is a single factor here, which is my teaching method. And I want to study its effect on a dependent variable. And what is a dependent variable here? My students' understanding of ANOVA. So this is one-way ANOVA. Now what is two-way ANOVA? It examines the effect of two factors on a dependent variable. So if I want to study the effect of my teaching as well as a student's intelligence on his understanding of ANOVA, it's a two-way test. Why? Because there are two factors I'm considering, my teaching method as well as the intelligence. So that's about the basic concepts we need to know about ANOVA. Let's now move on to the actual topic of our lesson, one-way ANOVA. Remember, ANOVA is the analysis of variance between two or more groups of data. And when we are dealing with multiple groups of data, we have two types of variances to consider. One is the within group variance and the second is the between group variance. As the name suggests, within group variance is the variance within each of the group you have. And between group variance is the variance between your groups. Now you can see that I have written SSW within the bracket against within group variance. You don't have to get confused. SS just means sum of squares and it's just another way of addressing variance. So if you see SS, this just means variance. So this is variance within the group, SSW, and this is variance between the group, SSB. Let's move on to the actual computation part. To compute one-way ANOVA, the first and foremost thing that you need to know is this formula. This formula says SS total is equal to SS between plus SS within, or as I already told you, SS is another way of addressing variance. So we can read this as total variance is equal to variance between the groups plus variance within the group. And you need to remember this formula to be able to solve your one-way ANOVA questions. The second important concept that we need to know is degree of freedom. So degree of freedom can be defined as maximum number of logically independent values which may vary in a data sample. I know this is a bit tricky definition. Let me try to explain this with an example. I have a class of 10 students and I have 10 chairs in my class. When the first student enters, the student has the freedom to choose any of the 10 chairs that is in the class. Once the student sits, the next student comes in. Okay. Now the second student has a choice among the 9 free chairs. In this way, the first 9 students have some level of choice to choose the chairs. Imagine all the 9 chairs are occupied, okay, and the last student comes in. Does the student has any freedom to choose the chair? No. He has just one chair left and he has to take that chair. So in my class of 10 students, only 9 students have the freedom to choose the chair and the degree of freedom in my class is 9. I hope you understand this. Let's study how we calculate degree of freedom. So just like we have three types of variance here, a total variance, a between group variance and a within group variance, we have three types of degree of freedom. One is total degree of freedom. So to calculate total degree of freedom, first we need to know total number of observations. And how do we know total number of observations? Suppose we have three groups of 5 observations each. Okay, so I have three groups and in each of those groups I have 5 observations. So what is my total number of observations? It would be 5 into 3, 15. So in my case, the total degree of freedom I will have for my data will be 15 minus 1, which will be 14. Okay. Now, the next is degree of freedom between the groups. For this, I need to subtract 1 from the total number of data sets which I represent with the letter K. I have 3 groups of data. So my total number of data sets is 3 minus 1, 2. So the degree of freedom between the groups here is 2. Third one, degree of freedom within the group. So for that, I have to subtract my total number of data sets from the total number of observations. So if you remember my example, I had 3 data sets of 5 observations each. So my total number of observations was 3 into 5, 15. And the total number of data sets, 3. So 15 minus 3, my DFW would be 12. So you need to understand these two concepts to be able to calculate one-way ANOVA. Let's solve our first question. So this question appeared in the term and examination of June 2023. And the question reads, compute one-way ANOVA parametric test for the following data. We know why ANOVA is called a parametric test. And this has nothing to do with solving this question. So you can just ignore this phrase here. What do we have? We are given 3 groups A, B and C and a bunch of numbers under this. How do we go about solving this question? We'll do a step-by-step study. So the first step is stating the hypothesis. So we'll state two hypotheses, a null hypothesis which says that there is no significant difference between the groups, and an alternate hypothesis which says there is a significant difference between the group. And we'll decide which of these hypotheses to accept and which of this is to be rejected by the end of the question. Now, irrespective of the number of groups you have or the data points you have or the question itself, you can write this as it is. For any question on solving ANOVA you get in your exam, the first step you can write this as it is. That the null hypothesis would be there is no significant difference between the groups. An alternate hypothesis, there is a significant difference between the groups. The second step would be to put the data in a table. So here I have already put a table. I suggest you do this along with me. I'll go slow, but you can pause the video anytime and take your own time to go through this. So I have this table here with 7 columns and 10 rows. I have group A in my first column and I've written down all the numbers. I have left last two rows blank, which I'll tell why. The second column I have for A square. So in this column you have to square all these values and write. Third column I have for group B and the values. Fourth column I have left blank for B square, then group C here and then C square. I have left the last column blank, which I'll tell you why. So you may pause the video here, make this table, write down these numbers and square each of these values and fill in these table. So this is my table after I have filled the square values. You can cross check your table with mine. So all throughout the question we'll be doing a lot of squaring work and lot of adding to find the sum. So I hope you have filled the columns and you have cross checked. The next step would be to add all the values under group A and write it here. Add all the values under group B and write it here. Add all the values under group C and write it here. You can again at this point pause the video, fill your numbers and then come back, cross check with mine. I got these values. Sum of A 16, sum of B 29, sum of C 44. Next we have to add up all the square values. We add up the square values of A and write it here, all the B square values and write it here, all the C square values and write it here. Again, feel free to pause and come back. These are the numbers that I have got. Sum of A square is 38, sum of B square is 121 and sum of C square is 328. Next, we have to add sum of A, sum of B and sum of C and write it here. Then we add sum of A square and sum of B square and sum of C square and write it in this row. And I've got these numbers. Sum of A plus sum of B plus sum of C is 89. Sum of a square plus sum of b square plus sum of c square is 487. I hope your table is finished till this point. Our third step now is to calculate the degrees of freedom. And for that, what do we need? We need k, we need n, and we need the capital N. K is the total number of groups, which is 3. Then there is small n, which is the total number of data points under each group. And we have 7 under each group. And capital N, that's the total number of data points, which would be 3 into 7, 21. Now let's calculate the degree of freedom. The total degree of freedom would be total number of observations, capital N, minus 1, which is 21 minus 1, 20. Then the degree of freedom between the groups, total number of data sets k minus 1, which is 3 minus 1, 2. Then we have degree of freedom within the groups, which is capital N minus k, which is 21 minus 3, and we have 18. Step 4, we calculate the correction term C. And this is the formula for correction term, which is sum of A plus sum of B plus sum of C whole square divided by N. Now this addition we have already done in our table. Remember, sum of A plus sum of B plus sum of C, we have already got the number 89. So we'll just simply go and substitute it there. We have 89 square by capital N, which was total number of observations, 21. And we get this number 377.19. I hope you were pausing videos as and when required and doing the calculations on your own and then cross-checking with mine. Step 5, we'll calculate the total sum of squares or the total variance. And the formula for this is sum of a square plus sum of b square plus sum of c square minus the correction term. Again, we have already calculated this part and this part. Remember the table? We have sum of a square plus sum of b square plus sum of c square, which is 487. We'll substitute the values 487 minus the correction term, which was 377.19, and we have this value 109.81. Step 6, we calculate the sum of squares between the group. Here we have to do a bit of calculation. The formula for variance between the group is sum of a whole square by n plus sum of b whole square by n plus sum of c whole square by n. The n here is small n, which is the number of observations in each group, which is 7 for us. Whole of this minus the correction term c. In our table, we know the sum of a is 16. So we have to square 16. We have to square 29. We have to square 44 also. And then divide each of these by 7. Add all of these and subtract the correction term from it. Or substituting the values, we have 16 square by 7 plus 29 square by 7 plus 44 square by 7 minus 377.19. We get this answer 56.09. Step 7, the formula comes. And what was the formula? The total variance or the total sum of squares is equal to variance between the groups plus variance within the group. We have already calculated the total variance and the variance between the groups. So if we substitute the value, we know that the variance within the group can be calculated by subtracting variance between the group from the total variance, or variance within the group is equal to total variance minus variance between the groups. We put in the values and we get 53.72. Step 8, we have to fill the ANOVA table. Now this is the format for the ANOVA table. You can copy this as it is. Here it says sum of squares, degrees of freedom, mean sum of squares, and in the first column you have to write with between, within, and total. We have already calculated some of these values. Let's just fill it in. So I have filled in the values. We have got sum of squares between the group as 56.09, sum of squares within the group 53.72, Total sum of squares 109.81. We also calculated the degrees of freedom. The degrees of freedom between the group is 2, degrees of freedom within the groups 18, total degrees of freedom 20. Now to calculate the mean sum of squares, what you need to do is you have to divide the value in this column by value in this column. So to calculate the mean sum of squares between the group, we divide 56.09 by 2. To calculate the mean sum of squares within the group, we divide 53.72 by 18. To calculate the mean sum of squares, which is total, we divide 109.81 by 20. And I got these values 28.045, 2.98 and 5.49. Step 9, we compute the F statistic. So if you remember, I had told you at the start of this video that the term variance was coined by R.A. Fisher. So this F statistic is in the memory of Fisher, who coined the term. So to calculate the F statistic, we divide the mean sum of square between the group by the mean sum of square within the group. So 28.045 by 2.98 and we get 9.41. After computing the F statistic, the last step is to compare the F value with the corresponding degrees of freedom on an F distribution table. This table you will find in internet or any statistics textbook. I have a screenshot of the table here. Not the full table, only just the part that we need in this question. So this is for a alpha value of 0.05. And you will see df1 here, which is degree of freedom 1, and here degree of freedom 2. So what we do is we'll find the critical value which coincide with df1 and df2. In this case, the df1 will be our degree of freedom between the groups and df2 will be our degree of freedom within the groups. So if you remember, what was the degree of freedom between the groups? 2. And what was the degree of freedom within the group? 18. So we'll take 2 here and then we'll scroll down to 18. This is 18. The critical value for our question is 3.55. So we write this, the critical value at 2, 18 is 3.55. What does this mean? We have to compare the critical value with our F statistic. You can see that the F statistic is much larger than the critical value 3.55. So the last statement that you need to write in this question is the calculated F statistic 9.41 is greater than the critical value 3.55. Hence, the null hypothesis is rejected, indicating a significant difference between the groups. What was the null hypothesis? That there is no significant difference between the groups. Now, in your examination, you will not be provided with a F distribution table. So, you can just finish your question here. And if you want, you can write that if the F statistic is greater than the critical value, null hypothesis will be rejected. Or if the F statistic smaller than the critical value, null hypothesis will be accepted. And even if you don't write any of this, you have got this F statistic correctly, you score full 10 marks. Let's now calculate another question. So this question came in the term and examination of December 2023 and it reads, compute one-way ANOVA parametric statistics for the following data. Now if you look at the statement, this is exactly same as what came for June 2023 also. And this is going to be the exact same statement that you will find in any of your previous year question papers. So what do we have here? Here we have group A, group B, group C, 3 groups with 5 values each in a group. So the step 1 is optional. If you want, you can write the null hypothesis, which would be there is no significant difference between the groups, and the alternate hypothesis that there is a significant difference between the groups. This is totally your choice. Then the next step, we put all these values into a table. I already have the table here. This is group A, this is group B, group C. I have put in the values. You can also make this table, add up these values and write here, and then add sum of A, sum of B, sum of C, write it in this row. So I've got sum of A as 14, sum of B as 28, and sum of C as 30, and the grand total 72. Next, you have to fill in the square column, A square here, B square here, and C square here. I have the values here. Next, we'll be calculating the sum of squares. Sum of A square here, sum of B square here, sum of C square here, and the grand total of all the squares here. I have sum of A square as 42, sum of B square as 174, sum of C square as 200, and the grand total 416. So we'll be using these two values, 72 and 416. Now we calculate our degrees of freedom first. We know K, that is the number of groups, is 3. Small n, number of observations in each group, 5. And capital N, the total number of observation, 5 into 3, 15. Total degrees of freedom, capital N minus 1, which is 15 minus 1, 14. Degrees of freedom between the groups, K minus 1, which is 3 minus 1, 2. Degrees of freedom within the groups, capital N minus K, which is 15 minus 3, 12. I am going a little faster because we have already solved the first question in detail. So you can, again I'm telling you, you can pause the video, do it yourself and come back and cross check. Next we calculate the correction term C, which is sum of A plus sum of B plus sum of C whole square by capital N. We have already got this value in the table. This is 72 square by 15, which is 345.6. Here we have the table 72, and for next formula we'll be using this number 416. So to calculate total sum of squares, we have the formula sum of A square plus sum of B square plus sum of C square minus the correction term C. So as I already mentioned, we have this number here 416 minus 345.6, which is 70.4. To calculate the sum of squares between the group, we have to calculate sum of A whole square by n plus sum of B whole square by n plus sum of C whole square by n minus the correction term. Putting in the values, we have 14 square by 5 plus 28 square by 5 plus 30 square by 5 minus 345.6, and we have 30.4. And how do we calculate the sum of squares within now? It is total sum of squares minus the sum of square between the groups. That is 70.4 minus 30.4, which is 40. We have all the values we need to fill in the ANOVA table. Now, this is the ANOVA table. I have already filled in the values here. How do we calculate the mean sum of squares? We divide this column by this column. 30.4 by 2 here, 40 by 12 here. 70.4 by 14 is optional. If you want, you can fill it here. These are the values: 15.2, 3.33 and 5.02. What is next? We calculate the F statistic. What was the formula for F statistic? This is the mean sum of squares between the group divided by mean sum of square within the group. Putting in the values, we have 15.2 by 3.33, which is 4.56. And if you get this number correctly, you have 10 marks in your pocket. If you want, you can write that if this value is bigger than the critical value, the null hypothesis will be rejected. Even if you don't write it, it's perfectly okay. Let's solve another question. It says, compute one-way ANOVA parametric statistics for the following data. The same question statement as I told you, and this one came in the term and examination of June 2024. What do we have here? We have 3 groups, and under each group, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We have 10 numbers under each group. I am not going to solve this question in detail. I am hoping that you will take it from here, solve it yourself, and you can just come back and check if you have got the correct answer. So the first step, optional. You can mention the null hypothesis that there is no significant difference between the groups, or the alternate hypothesis that there is a significant difference between the groups. Then you make the table. Since we have 3 groups, the table should have 7 columns and 10 values, so 13 rows. We can put in the values, add them up and write the sum of A, sum of B and sum of C. I have my table here. I have written in the values A, B, C and I've added them. Sum of A is 28, sum of B is 28, sum of C is also 28 and I've got the grand total of 84. And next, fill in A square, fill in B square, fill in C square, add all of it, then the grand total here. Here I have my A square values, B square values, C square values. Sum of A square 86, sum of B square 84, sum of C square 86 and the grand total 256. What is the next step? We find the degrees of freedom and the correction term. Small k, total number of groups 3. Small n, total number of observation in each group 10. Capital N, the total number of observation which is 10 into 3, 30. Total degree of freedom, capital N minus 1 which is 30 minus 1, 29. Degrees of freedom between the groups, k minus 1 which is 3 minus 1, 2. Degree of freedom within the groups, capital N minus k, 30 minus 3 which is 27. We have all the degrees of freedom. I hope you all got it correct. Then next, correction term C. Sum of A plus sum of B plus sum of C whole square by n. The value is already there in the table. You just have to substitute it in the formula. So it is 84 square by 30 which is 235.2. Next, we are going to calculate the sum of squares. The total sum of square, the formula is sum of A square plus sum of B square plus sum of C square minus the correction term C. Substituting the values, I got 20.8. Now, sum of squares between the groups, sum of A whole square by n plus sum of B whole square by n plus sum of C whole square by n minus the correction term, which on substitution I get 28 square by 10 plus 28 square by 10 plus 28 square by 10 minus 235.2 and my answer is 0. If you get a value like 0, you don't have to worry. This is pretty much possible in ANOVA. So if you get 0, just check if you have done everything correct before that and then move forward. So we have total sum of squares and we have sum of squares between the groups. So how do we calculate sum of square within the group? Total sum of square minus sum of square between the groups, which is 20.8 minus 0, which is 20.8, exactly same as the total sum of square. Since we have all the three values now, let's go and fill in the ANOVA table. Here I have filled in the table. I have divided this column by this column and got my mean sum of squares. 0 by 2, 0, 20.8 by 27, 0 0.770, 20.8 by 29, which is 0 0.717. Then last step, calculate the F statistic. How? Divide mean sum of squares between the group by mean sum of square within the group, which in case here is 0 by 0 0.770. So our F value is 0 again, which is pretty much possible. If you want, you can write that if the F statistic is greater than the critical value, null hypothesis is rejected. But if you have got 0, you have got all the 10 marks. Let's quickly do one last question, and this is the latest one. Compute one-way ANOVA parametric statistics for the following data, and this came in the term and examination of December 2024. What do we have? Group A, Group B, Group C, as usual 3 groups, and under each group we have 8 numbers. Okay, again I am going to go through this really fast. I'm hoping you will solve this yourself and then just cross check. What's the first step? Optional. Mention the null hypothesis and the alternative hypothesis. Step 2, make the table which has, because it has 3 groups, 7 columns, 8 values, so 8 plus 3, 11 rows. I have the table here. I have put in the A values. This is my total of A. Group B values, total of B. Group C values, total of C and the grand total 64. What is the next step? Add the square values here and here. Then you have to write the sum of the squares in this row and the grand total here. I have my values in place. You can check if you have got the values same as mine. Once this table is ready, next is we go and calculate the degrees of freedom. Our K is total number of groups 3, N is the total number of observations in each group 8, capital N is 8 into 3, 24, which is the total number of observations. Total degree of freedom is capital N minus 1, 24 minus 1, which is 23. Degrees of freedom between the group is K minus 1, which is 3 minus 1, 2. And degrees of freedom within the group is capital N minus K, which is 24 minus 3, 21. We have all these values. Let's go ahead with the correction term C. Formula is sum of A plus sum of B plus sum of C whole square by N. We have the values in the table. When you put the value, you get 64 square by 24, which is 170.67. Let's look at the sum of squares. The total sum of squares is sum of A square plus sum of B square plus sum of C square minus the correction term. Substituting the values, we get 188 minus 170.67, which is 17.33. Sum of square between the groups, what is the formula? Let's revise it. Sum of A whole square by N plus sum of B whole square by N plus sum of C whole square by N whole divided by correction term C. Substituting the values, we get 172 minus 170.67, which is 1.33. Finally, sum of square within the group, which is we subtract sum of sum of square between the group from the total sum of squares, and we get the value 16. We have all the sum of squares, and the next is putting the values in the ANOVA table and calculating the mean sum of squares here. So this is the table. I have the values here and the mean sum of squares 1.33 divided by 2, 0.665, 16 divided by 21, 0.761, 17.33 divided by 23, 0.753. Finally, the F statistic, mean sum of square between the group by mean sum of square within the group. And we get 0.87. And if you have got this value, again, congratulations, you have mastered one-way ANOVA. So the next doubt we can have is, like, if you go and practice any question from one-way ANOVA, how will you know that you have got the correct answer? Because I have solved here only 4 questions. You might be attempting some other question. Let me tell you how to check the correct answer. These are the links for the online tools. So what you can do is, if you're solving a question, you can go to one of these websites and then put in your data values and then compute the one-way ANOVA. It will tell you all the values. It will give you the whole ANOVA table, and it will calculate the F statistic also for you. Sadly, we cannot use this in the examination hall, so you have to learn how to calculate the F statistic, but this is for practice purposes. So I'll add this link in the description also. You can go and check. I hope you understood one-way ANOVA. We have come to the end of this video, and if you have understood one-way ANOVA, let me know by liking this video. And if you think this video will be of help to your friends, please feel free to share. And if you want to know when I am going to put my next video, please subscribe to this too. Keep learning with me, Dr. Swati. Bye bye.